Okay, so one thing that we're going to move to next is to talk a little bit about extreme levels of intelligence. And one way to evaluate the validity and significance of any test is to compare people who score at the two extremes of the normal curve, the low extreme and the high extreme. So let's take a look at these. So the low extreme of intelligence correlates with a diagnosis of intellectual disability. In order to diagnose an individual with intellectual disability, one has to have a low intelligence score. That is a score of 70 or below in terms of their IQ score on a standardized test. They have to have difficulty adapting to normal demands of independent living. This could include conceptual skills, their ability to think things through, social skills, their ability to relate to others, and practical skills, their daily living skills, their ability to take care of themselves. In mild forms, intellectual disability, like normal intelligence, can definitely result from a combination of genetic and environmental factors. In extreme forms of low intelligence, those usually end up being more significant organic difficulties or birth defects. Now, some folks really want to talk a little bit and challenge the idea about, is our IQ relatively stable over our lifetimes, or can it change? Now, there's been a lot of cross-sectional and longitudinal studies that show evidence that intellectual ability declines with age. Now, cross-sectional studies can look at different age groups simultaneously and compare them, whereas longitudinal studies look at a cohort, one group of people, and study them rather over a long term, over a longer period of time. So cross-sectional evidence, right? So people of different ages are compared with one another. When we do that, we can see that older adults give fewer correct answers on intelligence tests than younger adults, and that there is a clearly defined decline of mental ability with age as part of the general aging process. Longitudinal studies, I told you, are the same people, right? The same cohort of individuals that are restudied and retested over a longer period of time. And their findings indicate that intelligence remains stable, and on some tests, it actually even increases. So you're going to say, wait a second, how can it be stable, as longitudinal studies show, and how can it change as a cross-sectional studies show? Well, it really all depends. What happens is what are we really looking at and how are we measuring it? So we know that in longitudinal studies, when you follow people for a long period of time, we come to realize that intelligence might not be a single trait, but rather can be several distinct abilities. And as people age, different abilities take on a stronger precedence in their life, and different abilities can really maintain intellectual decline. Once we started taking a look at some of the participant loss in our longitudinal studies, we really noticed that a steeper decline really is not present in individuals until really especially after age 85. So many individuals can live well into their 70s and still maintain their high level of intellectual achievement. And then also we notice when you adjust for processing speed or you use wisdom tests, that might actually suggest that some of the intellectual competence in older people actually have not so much with how fast we process information, but how much information we've actually stored and processed over our lives. I guess the saying is true, with age comes wisdom. So let's take a look at take a look into some aging and intelligence. We can think of intelligence in two broadly defined areas with regards to the aging research, and that is crystallized intelligence versus fluid intelligence. And so crystallized intelligence actually increases as we age and actually increases well beyond middle age. So accumulated knowledge is reflected in vocabulary, and word power tests can be thought of as our crystallized intelligence. Our fluid intelligence is really our ability to reason speedily and abstractly, especially when solving unfamiliar logic problems. And this fluid intelligence, we know, conversely actually decreases with age. So it gradually declines until about age 75, and then it more rapidly declines after age 85. So again, we actually hold on to the accumulated knowledge that's reflected in our vocabulary and word power ability well into later years of our lives. But our fluid intelligence is really where the problem is as we age. And again, that's our ability to reason in a speedy fashion and to think abstractly. Let's move a little bit to talk about genetics and environment. So then, do people who share the same genes actually share the same mental abilities? So we, again, can use twin studies to study intellectual levels as people age, the same way we've studied many other characteristics and personality attributes of individuals. And we can really see that the heritability of intelligence really ranges from about 50 to 80%. So the heritability is the extent to which your intelligence scores variation can be attributed to genetic variation. Now again, 50 to 80%, that's a huge range. We know at least half of our intelligence ability is shared amongst our siblings, which is purely a result of inheritance and what we receive from our parents as offspring, but it can also go up to about 80%. So a lot of variability there. So then what accounts for the variability, right? Well, we know that genes and environment really work together. And specific genes actually have now begun to get pinpointed that seemingly might influence some variations in intelligence and learning disorders. So our genes shape our experiences. And if you had a natural aptitude for something, then you will do more of it. So in other words, if you have a genetic ability that tends to already make you on the smarter side, then you're going to be drawn to that area and you're going to seek out environmental experiences that actually continue to foster that ability. We know that there's no single DNA segment that can predict one's years of schooling or their achievement of what they can do in terms of educational achievement. And actually, genetic variations account for about 5% of differences in educational achievement. So that's a really small percentage. And other studies have replicated this very modest effect of genes on educational achievement. So what does this all mean? Well, if you're born with a little bit of smarts, then it certainly can take your environment to strengthen those smarts, but also your environment can have a huge impact as well. So where environments vary widely, we actually see that environmental differences are more predictive of intelligence scores. And when we know when children are adopted, that actually enhances the intelligence scores of particularly mistreated or neglected children. And adopted children who move away from mistreated and neglectful environments actually end up achieving higher rates of intellectual and academic achievement. We also can look at some of the studies of the intelligence scores of virtual twins, right? They're same age, unrelated siblings that are adopted as infants and raised together. And they have a correlation of 0.20. Now, that's not too far away from what we saw in terms of a huge genetic variability, right? So we know that actually almost a third of siblings who aren't even related biologically, but they're reared in the same household will actually be highly correlated in terms of their intelligence scores, simply because they share the same environment. Let's talk about gender. You might be wondering, how does gender fit into all this? Well, there does seem to be some gender similarities and differences. Compared to some of the similarities, gender differences are really fairly minor. We really see very small differences between boys and girls, which is unlike what folks normally think about gender in terms of kids. And they generally think that kids are, males versus females, where males are, tend to be better in math and females better in the arts. But really where we see gender differences really flourish is when it relates to the effects of our culture. And really it's social expectations and opportunities that really matter. And the little gender gap is found in actually gender equal cultures. And we actually have seen a huge increase in STEM programming in children, which is the sciences and technologies. And we've really seen schools that have STEM opportunities available for both boys and girls have equally successful outcomes in terms of both genders. So then if culture affects gender differences in terms of intelligence test scores, what do we generally see? Well, we generally see that girls outpace boys in terms of spelling and verbal fluency and locating objects. And girls outpace boys because they're better emotional detectors and are more sensitive to touch, taste, and color. Boys, on the other hand, outperform girls in tests of spatial abilities and complex math problems. And boys vary in their mental ability scores more often than girls do. So what does this all mean? Well, we might see some differences in early years of grade school, but as folks grow and as they become exposed to different opportunities, there's a real opportunity to close that gender gap in terms of intellectual differences and abilities. So that is a few things that I wanted to share with you all tonight in terms of our chapter 10 on intelligence. I'm sorry that the lecture was broken up to 2 pieces, and I will actually try to post both pieces separately as part 1 and part 2, so it can make it a little bit easier to kind of navigate through listening to chapter 10. Take care and have a great night.